Okay, let's keep going with question 4. Question 4, we do the opposite way as the previous. So now we're given the solution set. We want to use this solution set to write a quadratic equation. And remember, when we solve quadratic equation, we can always think the solutions as a vector. So let's see 8. We can write as x minus 3. Oh, let's start with this. So that means I have two x values, x equals to 3 and x equals to -1. But with these two equations, I can rewrite it as x minus 3 equals to 0. And x minus -1, which is x plus 1, equals to 0. Right? How did I get this? If I solve the equation by zero property, that means, well, we could think 0 times 0 would be 0. That means x minus 3 times x plus 1 equals to 0 times 0, which is 0. We can expand this two binomials. So we have 2x squared minus 3 plus 1 is minus 2x. Minus 3 times 1 is minus 3 equals to 0. So this is the equation for A. So as you can see, we're just doing backwards. When we solve equation, we go from this way, reach the solution, right? We start with x squared minus 2x minus 3 equals 0. This we see, oh, this is factorable. Then by using zero property, seeing the factors in the product to be 0, that means each factor can be 0. So we split into each factor to be 0, and then we solve for x. So this kind of question just do upwards, right? Just do opposite way. So we start with x equals 3, x equals -1. So we rewrite under the equation x minus 3 equals 0, x plus 1 equals 0. Then we put together because 0 times 0 would be 0, right? We expand. So same thing for B. We do the exactly same way. So for B, we have here. So I have x equals to half. I have x equals to 4. And that means x minus half equals to 0. And then x minus 4 equals to 0. 0 times 0 will be 0. So that means I can put those two factors together. X minus half times x minus 4 equals to 0. But then I see the fraction half, right? So I want to multiply by 2 on both sides. If I do that, let's do that. Multiply by 2, x minus half times x minus 4 equals 0 times 2, still 0. 0 times anything will be 0. Now I distribute 2 into the first parenthesis. So I get 2x, 2 times half, that's 1. Then x minus 4 equals to 0. So I don't have fraction anymore. The first factor becomes 2x minus 1. Second factor is x minus 4. Now I can expand 2x squared. Well, 2x times -4 gives me -8x. -1 times x gives me -1x. So together I get -9x. Then -1 times -4 gives me +4 equals 0. So we start with a solution. We write answer the equation. If we have fraction, we want to get rid of a fraction. But in this case, a fraction is half, so I multiply by 2. Then I expand, I get 2x squared minus 9x plus 4 equals 0 as the equation who has a solution of a half and 4. Let's see C. We're going to do exactly the same way. So I got x equals to 2i. Even it's complex solutions, but the way of forming or coming up with an equation is exactly the same. The process are the same. So complex solutions and irrational solutions come in pairs. So you see here, complex solutions have 2i and -2i. So they are conjugates. So the solutions come in pairs. So I write as x minus 2i equals to 0. x plus 2i equals to 0. 0 times 0 equals 0. I write x plus 2i in parentheses times x plus 2i in parentheses equals to 0. Then I FOIL out, I get x squared. Difference of two squares, right? Difference of two sums in complex. So x. This x squared plus 4 equals to 0. So in real numbers, we cannot factor sum of two squares. But in complex numbers, we can factor the sum of two squares because we use the property of I squared equals -1. Now let's see D. D, we have two irrational solutions. So irrational solutions also come in pairs. So they are conjugating each other. We do the same thing. We write as x equals to 2 plus radical 3. Let me write 3 first, and then I'm going to use my pencil to do the square root sign, okay? And x equals to 2 minus radical 3. So let me just use my pencil first. Right. So one solution is x equals to 2 plus 3. Second solution is x equals to 2 minus radical 3. Now I'm following the exact same process. I write x minus 2. Be careful here, we're minus 2 terms. So the minus sign affecting both of them. So minus 2 minus radical 3 equals to 0. Then x plus, well, let's keep writing minus, x minus 2 minus negative square root 3 becomes plus. Plus the square root 3 equals to 0. Let me put my square root sign. Then 0 times 0 will be 0, so I can put the two factors together. X minus 2 minus radical 3 as a factor. Then x minus 2 plus radical 3 as a second factor equals to 0. Let me put back my radical signs. Okay. Then to multiply out this, it might be a little bit trouble, but we could think as a difference of two squares, right? Which is just x squared, because we're treating x minus 2 as one thing. So we get two difference of two squares. So we get x minus 1. So first we'll treat minus 2. We're treating x minus 2 as one thing. So get this one squared. Then subtracting square root of 3 squared, which is just 3, equals to 0. So get this. Then x minus 2 squared is perfect square. We get the first one square minus 2 times x times -2, which is negative 4x. Then plus -2 squared, which is 4. Then minus 3 equals to 0. Right, 4 minus 3 is 1. So we get x squared minus 4x plus 1 is 0. All right. So let's just review a little bit. What did we do? Because the solutions are irrational solutions. They come in pairs. 2 plus radical 3, 2 minus radical 3. We call them conjugates. So what do? The process is exactly the same as before. We write down x equals to 2 plus radical 3, x equals to 2 minus radical 3. Then we want to write on one side, leave the right-hand side to be 0. So we put, so when we move 2 to the other side, it becomes negative. So we have x minus 2. When we move positive radical 3 to the other side, it becomes negative. So we have 2x minus 2 minus radical 3 equals 0. Same thing for the second solution of x. We move 2 to the other side, becomes negative. We move negative radical 3 to the other side, become positive. So we have x minus 2 plus radical 3 equals 0. Now, the two equations all equal to 0 can multiply those two. Multiply left with left-hand side, right-hand side with right-hand side. So left-hand side multiply left-hand side, we get x minus 2 minus radical 3 times x minus 2 plus radical 3. The right-hand side is 0 times 0, still 0. Then we're treating x minus 2 as one term for this moment. So we see we have difference of two squares. We have something minus radical 3, we have something plus radical 3. So there's something square, something in our case is x minus 2 square minus radical 3 square, which is as 3. Then we expand the perfect square of x minus 2. We get the first one square, second one square, then 2 times the first one times the second one, which is x times negative 2 times 2, which is negative 4x. Then 4 and negative 3 are like terms, adds up to be 1. So in the end, this is our solution for the equation. This is the equation who has a solution as 2 plus radical 3 and 2 minus radical 3, which is x squared minus 4x plus 1 equals to 0. Okay, that's question 4. Let's see, question 5, we want to graph quadratic functions. We want to identify vertex, intercepts, and axis of symmetry. Okay, let's see A. The function, right, for anything mathematics, we have 3 terms. We talk about expression, then equation, then function, all right? So this is 3 category. And of course, function belongs to equation family. So, first we learn expressions, we learn how to simplify expressions, or how to put expressions in the perfect form, in the form we want. And then we solve equations, solve for the variables. Then, we form a function, we use a function idea to model life applications. So later on, we're going to talk about to use quadratic functions to model life applications. Okay, let's see this one. We want to graph the following quadratic functions and identify the vertex, x-intercepts, y-intercepts, and the line of symmetry. So this form is called a vertex form. Remember, we have 3 forms. We have standard form, factored form, and vertex form. And so A, B, C, 3 of them in vertex form. So vertex form we have, let me just write it, standard form. We have A times x minus x squared plus k. In this case, h comma k is the vertex. Okay. All right. So remember what's the x-intercept? It was a y-intercept. Let me write it. So x-intercept means y value is 0. So we need to find out x value, but y value is 0. Similarly, y-intercept means x value is 0. If we want to find out a corresponding y value. So let's compare this with vertex form. Let's compare A with vertex form. So the number before the parenthesis decides if the graph goes downward or upward. Remember the graph of quadratic equations, either we have downward parabola or upward parabola. Right? We only have these 2 kinds of graphs. Either going upward or going downward. It's like you raise your 2 hands up or your 2 hands down. So going up and down is decided by such A. If A is positive, the A is called the leading coefficient. If it is positive, we get upward parabola. So 2 arms up. If A is negative, the parabola goes down. It's like 2 arms down. So in A, we see the coefficient A, leading coefficient A is positive. So for the first one, we get upward parabola. So we know we have those two hands up. And in the vertex form, we have h comma k to be the vertex. You see x minus h and plus k. So that means 4 is h, right? So this is the h value. And the k equals to -3 because we have plus k. So let's identify 4 and -3. So let's see, this is 1, 2, 3, 4. Right, so this is the value of 4. -3, maybe -1, -2, -3. So vertex will be here. Right, the vertex will be here. And it's upward parabola. Then we want to figure out x-intercept or y-intercept. Y-intercept is easier. We only have one y-intercept. That means x value is 0. If x value is 0, 0 minus 4 is -4. -4 squared is 16. 16 times 2, 32. 32 minus 3, 29. 29. So somewhere, I have to extend this. Somewhere in the faraway land, 29. So the y-intercept. Right. Then, so let me write this number down. So the y-intercept is 0, 29. What about x-intercept? X-intercept means the function value is 0, right? The function value is 0. Y is 0. That's the definition. We want to find the corresponding x. So we see this one. So this equals 0. We want to move -3 to the other side, become +3. Then we divide by 2 on both sides. So on the right-hand side, we got a 3/2. Then we have perfect square on the left-hand side. We want to take a square root, because square root cancel each other. So in that case, we got x minus 4 equals to plus minus 2 values of a square root. So allow me to write the square root as SQRT, 3/2. Otherwise, I have to constantly changing between pencil and typing. So then I move 4 to the other side, -4 move to the other, become +4. So I have 4 plus minus square root of 3/2. So I have two solutions, or this can be written as 4 plus minus square root of 6 divided by 2, because we want the denominator to be a rational number. So what did I do? I multiply square root 2 for the numerator and for the denominator. So square root 2 times square root 3 becomes square root of 6. Square root 2 times square root 2 becomes 2. So in the end, my solution is 4 plus square root of 6/2 and 4 minus square root of 6/2. So that's my two x-intercepts, right? So 4 plus square root radical 6, we know somewhere. So now I can graph my, line of symmetry. Line of symmetry, once we have the intercept, once we have the vertex, because our vertex is here. Once we have our vertex, the line symmetry is a vertical line going through the vertex, right? So this is line of symmetry. What is its name? The x value is 4. So the name of this line is x equals to 4. So my graph, but quadratic is not straight line. Okay, when we graph, we need to graph, like a curvish. Oops, it's very difficult to do, I know. So we have to try to make it smooth, like a roundish. And this is line of symmetry. I know my graph on the right-hand side of symmetry and on the left-hand side of symmetry are symmetric. So this is the graph for A. Right? I have two x-intercepts. One is here, one is here. And this one is 4 plus square root of 6 over 2. And this one is 4 minus square root of 6 over 2. My line of symmetry is x equals to 4. And then my y-intercept is 0, 29. My vertex is 4, negative 3. Okay, now let's see B. So very similarly, we want to identify our graph goes up or down. We see the negative 1 in front of x squared. So that means this graph of quadratic will be going downwards, right? Will be going downwards, 2 hands down somewhere. So what's h comma k? So this is plus is a minus negative, right? So h is negative 3. Plus k is 1. Right? So h is x value. So let's see negative 3, 1, negative 1, negative 2, negative 3, somewhere here. Then positive 1 somewhere here. So our vertex is here. That's our vertex. And our line of symmetry goes through this vertex parallel to y-axis. It's a vertical line. And what it is its name is x equals to negative 3. The x value of the vertex. Okay, now let's find a y-intercept. So we need to find the x-intercept, we need to find the y-intercept. Y-intercept means x value is 0. 0 plus 3 is 3. 3 squared is 9. But we have negative sign up front, so that's negative 9. Negative 9 plus 1 is negative 8. So somewhere negative 8, somewhere even down below here. Maybe somewhere here, negative 8. Okay. So that's my, oh, hold on. This is my y-axis. Let me mark my y-axis. This is my y-axis. That's the line of symmetry. Right? So negative 8 is somewhere here. So that's my y-intercept. So you can see the graph. So we have tried to smoothly. We have tried to make it like a curvish, not a straight lines. It has to pass by this y-intercept. Then if I want, I could do the symmetric line on the other side, right? If I graph without doing x-intercept. But we are asked to have x-intercept anyway. So what do? We set the function value to be 0. Then negative x plus 3 squared plus 1 is set to be 0 because the y value is 0. Right? Then we move positive 1 to the other side. We get negative 1. Negative 1, so we have negative sign on both sides. It's multiply negative 1 on both sides. We get an x plus 3 squared equals to 1. Now we're in a perfect state to square root because we have a perfect square on the left-hand side. We square both sides. We got a plus minus 2 values. So we get x plus 3 equals to plus minus 1. So plus minus 1. And x equals to negative 3 plus 1, that's negative 2. Negative 3 minus 1, that's negative 4. So I have two x-intercepts, negative 2, 0, and negative 4, 0. So this is negative 2, 0, and this is negative 4, 0. So that's our graph for B. Now let's see C. In C is positive, so we get an upward parabola. Get an upward parabola. 2 hands up. Hands up, hands up. Then let's identify our vertex. So x plus 1 is minus negative 1. So our h is negative 1. Let's say this is -1, so h is -1. And our k is -2. So -1, -2. Let's see, this is -2. This is -1. So right away, so our vertex is right here. Right away, our lines of symmetry goes through our vertex. It's just this line goes through our vertex. And what's the name of this vertical line? It's x equals to -1. So that's our lines of symmetry, x equals to -1. Now let's find our x-intercept. X-intercept means setting this to be 0. If we set this to be 0, move -2 to the other side. Don't think about these functions anymore. That means this. We move -2 to the other side and become positive. Now we divide by 3 on both sides. We get x plus 1 equals to 2 over plus minus, equal to 2 over 3. But then we can square root. So we have perfect square on the left-hand side. Let's square root. Square root, we got a plus minus 2 values. So right here for x plus 1 equals to square root of 2 over 3. So we move 1, we move positive 1 to the other side, becomes -1. So -1 plus or minus square root . So that's our two solutions. If we want to rationalize our denominator, we write as x equals to -1 plus or minus square root of, or multiply square root 3 in the numerator and in the denominator. Square root of 6 divided by 3. So now our denominator is 3. Right? It's not square root of 3. Okay, let's see D. D is in the standard form. We won't be able, I didn't finish C. I need to graph it, right? I need to graph it. So -1 plus square root of 6 over 3. I didn't find a y-intercept either. So y-intercept means x value equals 0. Let's find a y-intercept. We'll make a graph even easier. 0 plus 1 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 2, which is 1. So this is my y-axis. Let's see 1 is here. Right. So that's my y-intercept. So my y-intercept, once I have my y-intercept, I try to graph smoothly. Once I have half, I can graph the other half, right? Because they're symmetric. So I just pointed out this is -1 minus square root of 6 over 3. And this is -1 plus square root of 6 over 3. Now C is finished. So D is in a standard form, right? We see so ax squared, we see -1x squared, so a equals -1. And b equals 0 because we don't have x term. Right? C, of course, is just 5. All right, we want to identify vertex. Vertex has this formula. Let me write it here. X equals the x value of the vertex equals to -b over 2a. In our case, b is 0. So our vertex has x value to be 0. So that's our x value. Then our y value. Right? Our y value is just f. Input such x. F takes -b over 2a into its function. So in our case, b is 0, so x equals 0. Well, f of 0, what's f of 0? F of 0 is 5. So 0, 5. So 0, 5 is the vertex. And also y-intercept. Okay, also y-intercept because it falls on y-axis. So how do we graph it with all this information? Oh, we don't have, do we have roots yet? We don't have roots yet. So first we have downward parabola, right? Because a equals -1. So we know our parabola goes downward first. Then line of symmetry is y-axis because x equals 0. Well, x equals to 0 is another name for y-axis. And y equals 0 is another name for x-axis, right? So the vertex fall on this one, which is 0, 5. Let's mark 0, 5. So 0, 5. Let's see here. So this is our vertex, right? So our graph goes like something like this because downward parabola. But now let's find our x-intercept. X-intercept means we set the function value to be 0. So we get x squared equals to 5. X squared equals to 5. We square root both sides, right? So we get positive square root of 5, positive square root of 5 as comma 0 as one x-intercept, and then the other x-intercept is negative square root of 5, comma 0. Okay, so this is a graph of a D. All right, let me take a break and I'll keep going later on.